Hey everyone, how are you guys doing today? Put a 1 in the comments if this is your first time joining us for another SQL session. Awesome. Where are you guys from? I see, where is this? Where are you guys from? I'm from New York, so I'm watching this from New York. We got North Carolina in the building. Denver, Colorado. Baltimore. South Florida, UK. Welcome, UK. Awesome, awesome, awesome. Alrighty, so I'm going to give us a couple more seconds and wait for a couple more people to join, and then we'll begin. Please take the time right now to set up your database if you haven't already. It's in the pinned tabs on top of the comments section. If you guys haven't seen that, it's up there. I also do have a slide that's posted up there to show you how to connect your raw data to the database if you haven't already. So just please take the time to do so. Welcome, Nigeria. Thanks for joining. Alrighty, I'm gonna start. All right, so I am your host. My name is Alexis. Go by Lex. You can find me in the Discord. Please join our Discord. We have it in the comments above. The Discord link is there if you want to check us out. I'm currently in health information, trying to go into health informatics. And those are my social media handles. You can find me on Twitter at AMG in Tech, and you can find me in LinkedIn. Okay. All right, so today we actually have Ergus. He is our instructor for today. He has been in the world of data for the last 15 years, and he's well versed in SQL and analytics. And then we also have Jelly, who has been our coach before, instructor before. She has worked as a military analyst before completing the Google certificate, and she'll be your moderator for today. So you'll see her commenting in the YouTube channels for today. Awesome. So now I'll hand over the floor over to Erkus, and he will be able to begin.
All right. Welcome, everybody, to yet another SQL Saturday session. I will be your instructor today. Like Lexa said, I've been in the data field for the past 15 years or so. And I like the joke that SQL is my third language after Albanian and English. I'm originally from Albania. So today, I'm going to be talking about aggregates. So sums, counts, averages, stuff like that. I will be sharing my slides in a little bit. Feel free to switch over to my slides at any one point. So there is a slide in here about setting up your database. We're going to be using a website that's called SQLiteonline.com, and we're going to be using Postgres as our main database. So the instructions on how to set that up are on slide 4. I'm currently showing that slide.
I can't see this slide. I don't know if you guys can see it, and I just see all black.
Okay, let me try that again. I'm going to share my screen.
Yeah.
Is that your screen, Lex? Or is that mine?
That's mine currently.
Okay, let me quickly set this up. Google Slides. Okay, should be able to see mine.
Mm-hmm. Yeah, I just went black again for some reason.
Oh man. This is a bit strange. I'm using Firefox as my browser, so maybe that has something to do with it. Okay, well, we can also, I can let you go through the slides, and then I won't be able to show my screen. You know what I'm going to do? I'm going to reload the page.
Mm-hmm.
See if that. Okay, let me hit share screen. And then my text again. And then choose the slides. Oh, okay. Now it's showing. Okay, great. Well, I went full screen. I just went blank again.
All right, so maybe just half the screen, if anything.
Yeah, let me refresh the page. Okay. Sorry about that. I didn't realize this was going to be a problem. Okay, so I'll just leave it like this. Hopefully this will work.
Mm-hmm.
Okay, so these are the instructions to set up your database. We are going to be using this. This is what it looks like right here. So basically what you're going to zoom in a little bit, make this a bit bigger. So once you click on this and you go to the website, you download the Northwind database, which is here on GitHub. What I like to do is I like to click this raw button here. It gives me the file like this. Then I can right click the save page as and store it on my downloads folder. Once I've done that, I can go to post the SQLite online website. You want to click on PostgreSQL. There should be a link in here that says click to connect, just like I can see on this other database. Because mine is already set up, you don't see that. So from the file menu here, you do open SQL. It's here in my downloads folder. I open and then I just click run. And it takes about a second, and it should set up your screen, uh, should set up your database ready for today's session. Okay, cool. So now let's start talking about aggregates. Well, what are aggregates? Aggregates allow you to summarize data from a table. And by summarizing, we mean things like counting how many rows are there, being able to sum certain numerical values, being able to get averages, and things of that matter. So an aggregate is basically a sum or a count. It's basically a summary of the rows. And what happens when you aggregate data, you're basically reducing the number of rows that you are showing. And you can then see like how many rows are there in a table, what the sum is, et cetera, et cetera. We're going to go into detail on how to use this thing, but this is a very simple intro to um, to aggregates. Let's just take a look at what this is what the select statement does. So basically what we do when we do select count, And then we put this little star in here. The star means count everything, count all the rows as total orders. So we're giving it a name as total orders. And then we're doing a sum of quantity from the order details table. So this gives us all the number of rows and the sum of the total orders that were sold. Let's copy this into SQL here. Hopefully people can see my screen. Otherwise, I can zoom in a little bit more. So once we paste the code here, we can hit run. And here we go. We have a total of 2,155 total orders and a quantity of 51,000. So this is a way to kind of get a summary of what's going on in a table. As you all know, select star is a way to get like all the data from a table. So this gives us all the information that's in the table. So there's things in here, the order ID, the product ID, the unit price, quantity, etc. But if we wanted to know how many orders are there and what is the total number of quantities, we just do we do count star as total orders, sum of quantity as total quantity from order details. And we run that and we get one row.
Fergus, can you actually zoom in just a tad bit more to the code?
Of the code?
Sure. Mm-hmm. Thank you.
Mm-hmm. Okay, so that is a very basic aggregate function. Count star is a very basic aggregate function, and we're just doing a simple count and a simple sum from one table. Let's do something a little bit more complicated. What if we wanted to summarize some order details that includes information about the order itself? So we have an orders table and then we have an order details table. The orders table actually has all of the orders that were sold, and then the order details has the details of each order, the quantity, the amount that was paid, etc., etc. In this query, we're doing the same as before. We're doing select count star as total orders, and then we are summing the quantity. But at the same time, we're doing a calculation in here. So we're multiplying the unit price with the quantity, and that gives us gross revenue. As all the finance folks would know, gross revenue just means money that's coming in. This does not take into account any costs that were incurred during that order. In our case, these costs come in the form of discounts. So discounts are a way of basically selling the product for a little bit cheaper. So what that means is that if we want the actual revenue, net revenue, would have to get the gross revenue minus total discount. Now, one simple way to do that is by just doing the calculation right here. You can do sum of this minus sum of this. So here's another way that you can do aggregate functions inside of SQL. You can actually perform calculations using these aggregate functions, sum and count. And we'll do another one later that you'll see when we divide the sum with the total number of orders. Let's see what this gives us. So I'm going to copy this code, head on over to SQLLiteOnline.com, paste the code here, and hit run. And what we get is 2,155 orders, 51,000 total quantity. At the same time, we get a revenue here, a revenue number. This is about 1.3 million, I believe, of gross revenue and $121 in total discount. And so the net revenue is 1.3 million basically $121 less. So just like that, in a very simple query, utilizing the sum and the count, we're able to get a quick overview of how the business is doing. In this case, we have a total of, $1.3 million in revenue, which is not bad at all. But we're doing something else in here. We're joining the orders table with the order details table. Why do we do that? Well, the orders table has information about the orders, and the order details has information that is specific to each order. So I think the tables are connected to each other in a one-to-one relationship. Okay, that was a quick summary of how to use join and aggregates. So you can actually do a join and aggregates. And I will kind of stop there and see if there's any questions. I want to probably go over to the YouTube page and see if I can see any questions as well, or we can continue onto the next slide. Lex, any questions?
No questions, but I am just going to say if you can pause just for a couple seconds, just because I believe previously the wrong raw data link was pinned. So we're just making sure that everyone had got the
Okay.
GitHub connected.
Of course. Okay, I'm seeing some questions about setting things up. I can quickly run through that again if that's what's needed here. So what you do is once you download the SQL file, you open this page, you basically open up the PostgreSQL link. It wouldn't look like this, right? It shouldn't look like this at first. It should look like this. It would say click to connect. You click to connect basically, and you will see only a demo table initially. Then you load in your file that you downloaded, northwind.sql, and you hit run, and that will populate your database with all these tables. Okay. Shall we continue?
Yep.
Okay, great. Okay, so we just saw a very quick demo of, I'm going to hide this. We just saw a very quick demo of how to do some summary. So we're doing sum of quantity as total quantity. We're multiplying a unit price with the quantity and then summing that. That gives us gross revenue. We're summing up the discount. And over here, we're doing sum of this minus this, and this is giving us net revenue. Okay, let's jump on to something a little bit more complex. Okay, well, this looks like a very big query, but it's really very similar to the one before. In this query, what we're doing is we are doing the same as before. So we are summing the quantity, we're summing up the discount as net revenue, but we're adding another little thing in here. We're adding the order date. So when you do aggregates, one of the ways that you'll end up doing aggregates a lot is something known as doing a breakdown. So breaking down orders by order date, or by order type, or by product type, or by customer type, and so on and so forth. These are very common questions in SQL, very common reporting requests. So the way that you do that is you use the group by clause in SQL. So the group by clause is used anytime that you use a column in the select that is not aggregated. So you'll see here, all these columns are aggregated. So we have a count and a sum, and we're also doing this calculation of sum of unit price times quantity divided by the count as the average order value. But at the same time, we have a column in here that is not grouped. And what that does is it basically breaks down this total. Instead of us having one row, we now have just one total row. We have multiple rows by date. The way that we do that is by adding a group by clause, group by order date, right after our join. So group by comes after the from, after the join, you add the group by. And we can also do kind of an order by, because we want to see these orders sorted by the order date. Let's paste this query here and see what we get. So when I run this, okay, now we're getting an order date, and we get the same sort of columns that we had before. We have the total orders, the total quantity, gross revenue, discount, and net revenue. We also have this average order value. Average order value is actually a very important metric when it comes to analyzing e-commerce or any sort of sales type data. It's actually a way to measure how well you're performing, right? So you want to see, well, okay, we had 1,000 orders, but what was the average order value? Was it like $1? In which case, okay, it's only $1,000. Or was it $10? In which case we had, $10,000 in total sales. And the goal is always to increase that average order value to make sure that you're basically getting more revenue. At the same time, we are grouping or breaking down that total that we saw by date. So let me go back to that so I can show you what we had before. What we had before is we only had total orders, so one single row, right? And then when we add the order date, we get one row per date. So every day we can now see how many orders we had per day. What we can do with this information is we can graph this with the date on the x-axis and the total orders on the y-axis. And then we get basically a nice line chart that shows us how are we performing over time. Is it increasing? Is it decreasing? Or is it staying roughly the same? This is also, again, a very common way of doing analysis with SQL. A lot of sales managers, marketing managers will want to know, okay, how are we performing day over day? And you'll probably be asked to do something like this. Well, another thing, now that we look at this, is we have one row per day. But typically, when a business is measuring their performance, they look at the orders by day, but sometimes, actually very often, they look at the orders on a month and year level, so that they can compare month over month, how are we doing, or year over year, how are we doing. But we don't have year anywhere in here, right? We only have an order date. We don't have month, we don't have year. Well, we do. It's actually embedded in this date field. And in order to extract it, in order to pull it out, we have to use a function in Postgres that's known as datepart. This is a common function in Postgres that allows you to basically extract parts of the date. You can extract the month, you can extract the year, you can extract the day, the minute, the hour, the second, and so on and so forth. This allows you almost like an infinite level of detail on your analysis. So you can, perhaps you want to compare things year over year, month over month, but also quarter over quarter. Some companies want to look at things on a quarterly level. The date actually contains all that information kind of embedded in its concept. It has like all these layers of all these layers of granularity, or they're also known, so that they're known as levels of detail or levels of granularity of the data. How granular is your data? Is it super granular, which is at the, say, at the day level or at the hour level, or is it very coarse? Is it like at the month level, or is it at the year level? This function allows us to create an almost infinite number of reports just from the date without having to have the date. And notice in here, when we do a group by, we have to basically copy this whole thing into the group by and also into the order by. That's a bit of a requirement from SQL, but there is a way around it, which I'll show in the next slide. Don't want to get too far ahead of myself here. So let us then select everything here and paste this code here, hit run. Okay, now we only get 12 rows. So we get order month and we get a number here. We don't get the name of the month. We can, I think there is a function to get the name of the month, but that's not we're not demonstrating that here. We're kind of just showing what do we get, how many orders do we get per month. So this is another way that we can look at the same data, but we're grouping it at a different level. We're aggregating the data at a different level, because here we have it every month. But notice that there's something missing here. We're missing the year. And we saw earlier that we had data from multiple years, from 1996, 1997, 1998. So what happened to the year? Well, when we did date part, we're basically extracting only the month. And so these total orders here are across multiple years. I would not recommend that you show this report to anyone, because you will likely confuse them. They will assume that these are orders from, say, last year, which in this particular query, they're not. They're orders across multiple years. So how do we do that? How do we get the year added to this query? That's what we're going to be covering next. But before we go there, I want to make sure that there aren't any questions. Next, do we have any questions? I'm not seeing anything on the chat. Don't be shy. I'm here to answer any and all your questions. And okay, is there an advantage to doing time series analysis in SQL versus Excel or Tableau? That's a good question. So the advantage here is that you're doing things quickly. You this is a way of just checking things. If you just want to pull some data, copy and paste it into Excel, and do a quick line chart, or some modern uh, data warehouses allow you to do like a quick chart from within the tool itself. Like Snowflake does that, BigQuery does that. That way you can quickly look at your data and see how you're doing. Make sure that you're actually doing okay. So the advantage is only that you will be able to get an answer quickly. Basically, check yourself, make sure you're getting the right thing. Um, Tools like Tableau, Power BI, or Looker, they don't like data to be aggregated at this level. They want you to give them very low level data, basically the order table, and then they themselves allow you to do all these levels of aggregation, right? So behind the scenes, what Tableau and Looker and Power BI is doing is constructing these SQL queries that we built by hand and running them on the database. If you are designing a report that will then be shown to business stakeholders like VP of sales, etc., they will probably that you will not need to be sort of doing this yourself. This is more for any analyst that's doing, like a quick analysis on data before you dump it into Excel or into any other tool. So yeah, so that's sort of the advantage. Um, Hope I answered your question. Very good question, by the way. For those of you that don't know what these tools are, so Tableau, Looker, Power BI, these are tools that allow you to create reports on top of your data. They make it super easy to basically do what we just did by hand, but in a very kind of visual, automated way. Okay, I will move on to the next slide, where we get to see how do we break down orders both by month and by year. Also, to kind of add to Kadish's question, oftentimes you'll be using aggregates to reduce the granularity on a table before joining it with other tables in your query, like if you're writing a very complex query. So you will have to, by default, like do all the calculations in SQL as you're joining tables, and then kind of create one table that is then used for reporting. So you will definitely be using this in a day-to-day if you're writing complex queries. So this is very good to kind of understand basically at a conceptual level. Okay, so what we're doing here is we're doing two levels. We're doing two columns. We're taking the date and extracting both the month and the year out of it. So it's the same as the query before. So in here we're doing, so date part and extract are similar functions. I just wanted to make sure that you could see multiple uses. I could have also done date part month, date part year, but I wanted to show the Postgres has this function called extract month from order date, extract year from order date. And we're basically calculating the same metrics. Now here's something that I didn't show in the previous slide. Here's a very, very nice way, very simple way to do group by and order by. You'll see that I used like a 1, 2 here. What does that mean? It means the first column and the second column in that order. So group by the first column first, second column second. Order by the second column first, first column second. Okay, what that does is it makes it easier So we don't have to type all of this stuff, because sometimes these calculations here can get very complicated. You could be using case statements to kind of break things down further. And your group by is going to look very, very messy if you copied and pasted the exact formula here in the group by. And so modern databases allow you to bypass all that and just do group by 1, 2. If I had 10 columns here, I would do 1, comma 2, comma 3, comma 4, etc., comma 10. So that allows me to group by all the columns. Now, one thing that is important to note here, if one of these columns appears after, so if this was actually the last column for whatever reason, then grouping by that column I would have to actually count how many columns that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'd have to do group by 1, 2, comma 9. Now, I personally don't recommend doing this. I like to put all the columns that I'm grouping by first, right after my select, so that I can do group by 1, 2, 3, 4, 5, right? It's a lot easier that way. And then have all the aggregate columns come next. This is just kind of a rule of thumb that I've learned over many years of writing SQL. So let's see what this looks like. I'm going to make sure I'm going to select everything here, delete it, and paste this new query here. Now that we run it, okay. So as you see here, the orders begin in, what is this, July, August? July, I think, July of 1996, right? And then they go through 1996 and then 1997, January through December, and then 1998, January through May, actually. Okay, so now you can see that, as we had in the previous slide, in the previous query, it's not just 12 rows because they have multiple years baked in. Now you can do an order month and an order year. We can see exactly what's going on. And we can then kind of gain a sense of how we're doing in terms of total orders. We had all 59 orders here, 69, and 96 up here, 95, 106. So it looks like our business is doing better. It's perhaps improving over time. Another thing that this allows us to see is seasonality. So when do orders pick up versus when there's a slump that is sort of natural as part of the seasonality. So this is a way to do that for just extracting from the order date, the year, and the month. Okay, want to see. Let's look at something else. So up until now, we were looking at orders by date. Well, there's a products table as well. So maybe I wanted to see orders by product name. It's essentially the same query as before, except now we're joining the products. So now you'll see that I can add as many columns as I want here in my join. And then the group by is always last. And if you use an order by, that's usually that comes right after group by. In this particular query, we're only looking at the orders by product type. So this is another way of doing like a breaking down orders by product type. Okay, so I don't want to try to misspell some of these product names because they appear to be in another language, but I see tofu here and Carnarvon tigers and so on and so forth. So now you can see by different products the different types of orders that, tea time chocolate biscuits, 37 of them. What we can do here perhaps is we can do kind of an order by total orders. And I can do DSSC, which means I want it in descending order. This will give me a quick way to see what happened to my query here. Why am I not getting anything? Oh, maybe I'll do order by 2. Descending. Okay. I guess it doesn't like my column name. Okay, so now this gives us a way to see which one was the most popular product. Which one did we have the most sales on? In this case, it was this product here, Cordovo, Raclette Cordovo. I'm guessing this is how you pronounce this. It had this many total orders. Oh, but wait, there is a quantity column. Maybe I want to see what this looks like by quantity. Quantity is the third column, so let me do order by 3 descending. Okay, so this product is now actually the first one. Well, I'm not going to try to pronounce it again. It had fewer total orders, but it had a lot more quantity sold. And this one that was first before is now second. So this is another way of kind of doing a quick report on your data. Again, modern BI tools like Tableau, Looker, Power BI, they make all of this very easy. They allow you to group by any column, sort and filter by multiple columns. But there will be times when you just want to run a quick query on the orders to see how you're doing without having to kind of put this into like a modern BI tool. All right, let's see if there's any questions. Okay, I'm not seeing any questions. Come on, everybody, don't be shy. Okay, some good comments out there. Okay. Well, there is another piece of coding that we yet need to cover when it comes to aggregates, and that is known as filtering. Okay, so let's say your the sales manager asks you to give them all the orders that, like all the products that had 10 or more sales. Okay, well, typically, if you are familiar with like the basic SQL, you'll be thinking, well, I could put this in the where clause. When it comes to aggregates, however, the where clause does not work for the aggregate columns. So in the where clause, I can put only the columns that are not aggregated. And that would have to go somewhere right after the join before the group by. However, if I wanted to filter after the aggregates, I'd have to use this keyword called having. Having is a way to filter aggregates, and it always comes last. So I think it comes right after group by. I think it's before order by. But it's a way to filter the aggregates themselves. So let's run this query here. Okay. Well, I'm not seeing any. Let me order this just so that you can see if this is working or not. So I'm going to order by, say, total orders. This is the third column. So I'm going to do the third column. And I want this in ascending order because I want a minimum of 10. Okay, so now I see that Grandma Boysenberry spread sold 12, and then this number is kind of increasing 12, 13, 14, and so on until the last product that was sold 54. Notice that we've added another column in here. We've added the category name. We get that from the categories by joining categories to products on category ID. And we still do the group by. Now you'll notice this order is very important. Group by comes first, having comes next, order by is always last. Now, what if I wanted to use the where clause here? Well, it has to come right after here. And I'd have to say, let's say that I only wanted to look at confections. So category name equals confections. Now I can both filter by category name and I can filter by the aggregate. Okay, so I can look at all the products that had at least 10 total orders or more, and they're only confections. Okay, so here's basically a way that you can combine. Let me just try to get the full query here. Here's how you can combine the where, the group by, the having, and the order by. The order of these keywords is very important. If you put them in the wrong order, SQL will complain. Let's see what happens if I were to say, if I were to try to do where total quantity is greater than 10. And then let me just remove this. Well, we don't get an error shown here. I think maybe the error shows up on the right. Aha, column total quantity does not exist. You might be confused by this error because you're saying, hey, I created total quantity. Well, why does it say doesn't exist? Well, it doesn't exist because it is an aggregate column, and you cannot use aggregates in the where clause. That is a very important thing to keep in mind. So I could put the product name, I can put the category name in the where clause, but I cannot put any of these calculated columns, any of these aggregate columns. To filter those, I would have to use having in this particular way. Okay, so I think that this one is a bit of a complicated one. So before I jump on to the next one, I want to see if there's any questions. Let's see. I like that one. Smelly feet will give horrible odors. Yeah, after a while, you kind of learn the order of these keywords. Where, yeah, you'll see that one here. SF, what is it? SFW GHO. Yes, that is correct. I don't have the where here, but yes. Yeah, here we go. Well, there's the J's in here, which are not in your thing, but yes, that's pretty much how you have to remember this thing. Yeah, I mean, even just getting to this level, this is fairly complicated stuff that like people that are just getting started with SQL can get hung up on a lot of these details in here. But yeah. Okay. So I have one more slide to cover, and then we can get into the questions. And I just wanted to show with this particular slide, okay, I only want to show orders that have an average order value of greater than 50. I wanted to show that you can actually put calculations in this, just like you can do in the where clause. And you can mostly copy paste what the aggregate is and put it into the having clause and be able to quickly filter your orders. So I just want to show you that this also works. But in order to show that, I think I want to order by, let me see, that would be average order value. That is column number, it's not number 9 here because the select doesn't count. So it's column number 8, descending, I believe. Let's try that. Okay. And average order value, it's over here. Oh, I'm ordering them in descending order. 1 second, let me change this. Ascending order. I want to see what the smallest one is. And here we go. Average order value 53.54, and then it goes up from there. Okay, so this is basically another way of filtering, but I wanted to show you that you can indeed put in like calculations in here. A lot of ratios and things like that you can actually calculate them in SQL, and then you can put them in your filter. Again, going back to the question that Kadisha had earlier, you probably wouldn't be doing this for traditional reports that will be used by the business executives. But if you yourself wanted to quickly check things, then yes, you should probably know how this stuff works. Okay. Well, that's pretty much all the information that I had for today. It's just me today. There is no second instructor. So you only get like a flavor, a bit of a taste for aggregates. But I'm going to see in here if there's any questions. Bruce, yeah, it's slightly more advanced today, but I'm happy to answer any detailed questions that may come. If not, then I want to kindly remind you to complete our survey. Let us know how we're doing. Let us know what other things you'd like to learn from SQL Saturdays. We're always happy to add more topics, add more instructors, and basically cover any and all questions you might have. Okay, I see a question. Does having always go with group by? Yes, it does. Having only goes with group by. Having only works with group by. The having does not work if you're not doing any group bys. So if I was simply, if I was not doing any grouping in here, having will basically fail. We got an error. Product name must appear in the group by. Yes. I'll give you one quick use for having. One of the ways that I use it a lot is to check for duplicates in a table. So if, say, the orders table is supposed to have like only one order per order ID, then I can do a quick I can run a quick query that says select order ID, and count star. And I want to remove all of these things. And I want to say having count star greater than 1. I should get no results because the order table should only have one row per order ID. Did I get an error here? Must appear in the group by. Oh, I forgot to do a group by, of course. Group by 1. Okay, that worked, but again, we got no results, which is a good thing. So this is one way that I use group by in having when I'm checking my tables, because having duplicate rows in a table will mess up your reporting. And this is one of the quickest way to check for duplicates in a table. Anyways, that's a nice little bonus lesson for you. Thank you, everyone. You can find me on Twitter at ErgustX and on LinkedIn. And we have Jelly here, who's been kind of helping run today's session. You can find her on @TechGirlJelly and on LinkedIn.
Yep, guys. So thanks for joining this session. If you guys have any more questions, please feel free. You can actually continue commenting. We'll be on for a few more moments. You can also reach us in the Discord. We have our Discord link pinned in the comments. You can find it there, so you can join the Discord. You can always message one of us regarding any of these SQL stuff. If you enter a SQL channel, you'll be able to access the presentation slides that we had used today. So if you ever want to replay this video and follow along and look at the codes that we entered, it's all in those slides. So thanks again for joining us. You enjoy the rest of your Saturdays. We'll still be here, but you enjoy the rest of your Saturday. And yeah, thanks.
Thanks, everyone. Have a wonderful weekend.